Welcome. Today we will have a closer look how the signing works. So generally speaking, whenever we want to do a transaction, we have the transaction itself and it has to be signed, and then the signed transaction is submitted to the XRP ledger and then validated. And today we will figure out and look a little bit more closely how the entire signing process works. So first of all, we will have to look into how transactions generally look like. And you can see here that I've prepared something. So you can see here, so the format we've got here is so-called JSON. The acronym is for JavaScript Object Notation. And we can see here, it's always a mapping between a value, between a property and a value. You can see here that the transaction type, and the type is payment. The account is this address here, the fee is 12, and so on. So they're just like key value mappings here. This transaction, so this is a standard, or they are standardized and defined on the website here. So you can see which fields the XRP ledger expects from you. And for example, if you want to do a JSON payment, you can see here it wants you to define the transaction type. So the fields are defined here is below. So you can see the amount should be of type currency amount, and then there's the definition what the currency amount object looks like. And so these are nested objects. And this is what the XRP ledger expects from you, for example, for payment, but also, for example, if you want to change a property in the account, then you can do an account set. For example, if you set the message key and the domain. Or if you want to create an escrow, then the XRP ledger expects a different format. It still wants to know the basic fields, the account, transaction type of escrow create, destination, and some additional fields. For example, also a condition if you want to use a crypto condition. So this is the premise, or the preset we need to know and understand. So we've got these text, messages or objects, which have to be submitted to the XRP ledger. And if we just, for example, send that to the XRP ledger, how should the XRP ledger know if we are allowed to do that or not? Because it could just enter in the account field any account address I'd like to. So there must be some kind of authorization. So for example, if we would just go there to any transaction which just happened here, and if it would just enter that and then submit it to the XRP ledger, it would be problematic if it would be just able to specify that and the change gets applied. And that's why transactions have to be signed. So you are signing every transaction. So whenever you use any hardware or software wallet, the signing happens. So it takes your private key, and this message here gets signed with your private key. And after it is signed, it gets submitted to the XRP ledger, and the XRP ledger can validate if the account owner, so if this message has been signed by the account owner. So these are the basics of, well, more or less cryptography right now. And if you want to do that, I prepared here a simple tool to do that. And you can see here that's a transaction. Then it wants the family seed. So I will just generate quickly one on the testnet. I just want to go quickly to faucet. So we can see here it is the faucet. And I'm just going to generate credentials here. So let's take this secret here, doesn't matter. So I've got the transaction here. Then I've got the secret, the family seed. And now I'm going to sign it. And what happens, this transaction gets signed, and this is what it looks like afterwards. So this is a hex, it's a transaction blob. It's in hexadecimal. Yeah, that's how all of that, not hexadecimal, it's in hex. So, but okay, yeah. But let's continue. So this is, it's a hex blob, obviously. So yeah, this is the transaction blob, which gets then submitted to the XRP ledger. And like I said, it can then verify. So there are multiple fields which gets submitted to the XRP ledger. So Wietse also wrote an article on that, which I'm going to quickly cite here. So it's down here. So I'm just going to highlight it here, so you can see here that the transaction. So what was being sent here. So like I said, with the private key which we just used, we sign it. So it's the signature more or less. Then the public key gets submitted, and also the transaction message. And with transaction message, we exactly mean this part here. That's the transaction message. And all of that gets submitted to the XRP ledger, and the XRP ledger can then, you can see here Ripple D, so that's the Ripple daemon, generally speaking, the software which is running on multiple computers or servers more or less, which are called in the union the XRP ledger. So they are able to verify by just using, so now I have to be careful that I don't say something wrong again. So they're just taking the signed object, and I think they're, well, okay, hopefully I'm not mixing anything up here. So it takes the hashed transaction message, so the hashed transaction is being signed, and then the XRP ledger decrypts the signed message. So it takes the public key to decrypt the signed message, and then it checks if the hash of the transaction message equals the hash if you reverse that. So because because we are signing, so we're more or less encrypting the hash into a signature, and if you decrypt it using the public key, you should get the initial hash. So that's the transaction is sent there, the transaction is being hashed, and then it's compared with the signed hash, which is being decrypted using the public key, and then if those two match, then it's an okay, and if it isn't, then the XRP ledger says, nope, the signature doesn't match, so I'm gonna deny that. And that's how, generally speaking, all of it works, and I just wanted to highlight it in this app here, so in this simple, in a simple web application here. So having a transaction, signing it, if whatever change of field, obviously the transaction blob looks differently again. So any change changes obviously the entire blob here, and yeah, that's how all of it works. I hope I was able to make it a little bit clear, to make it a little bit more clear. And yeah, thanks for watching, and see you in the next video.